Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running nationally syndicated radio talk show on computers and technology. And ladies and gentlemen, paper clips, bubble gum, and dental floss, and a bit of MacGyver. Ladies and gentlemen, those are what really hold the tech world together, and especially our tech world today. So some things happen behind the scenes, but ladies and gentlemen, suffice to say, it's all going to be okay, and we have a show for you today, because today on the program, we have the one, the only, Mr. Ralph Bond. He'll be joining us here in just a moment to talk about a number of stories, that number being 4, and these stories are going to be, fun, uplifting, they're going to be interesting. We're going to talk about, light-based chips, because sometimes, hey, you just need 10 gig speeds with no cables. It's just really amazing what some of these stories are going to bring you. And odds are you haven't heard of really a lot of these because the headlines are dominated by so many other things. Ralph comes to us every single Friday with 4 amazing stories that, oddly enough, don't get a lot of attention. So join us here in just a moment. Before that, computeramerica.com. That's where you'll find past shows, future shows, show notes that are accurate 99% of the time. It is crazy. We'll talk about that 1% inaccuracy when Ralph gets on. That was when we recorded and something happened that didn't happen. And yeah, we'll talk about that in just a moment. But ladies and gentlemen, computeramerica.com, I promise, is still the best place. So with that being said, let's go ahead, bring Ralph on, and just have fun with it. And once again, he's a longtime contributor to Computer America. He has become our science and tech trends correspondent. And ladies and gentlemen, welcome him back onto the program. Ralph, how you been?
I'm doing great. And yeah, we'll correct that correction in just a moment here. But for people who are new to the show, want to set the stage for you. What Ben and I do each Friday, we highlight 4 recent articles that show us key trends and developments in all kinds of stuff: artificial intelligence, robotics, medical technology, sustainable energy technology, transportation advances, agricultural technology, space research, physics. Wow, you name it, all across the board. And most important of all, we're going to give you an oasis of positive news thanks to the world of science and technology.
Absolutely. And you have some amazing stories, which I actually have the first one up on the screen. It's going to be a weird show, folks. But yeah, before we get into our, today's show notes, let's go ahead and talk about before, because due to some scheduling error or some scheduling conflicts and stuff like that, we actually recorded something that, a correction should be made after the fact. And Ralph, you may know off the top of your head, it was not the space launch that has been delayed to try to get those poor astronauts home. It was a different space launch that was also delayed. And I believe that was the story that we did 2 weeks ago, that they were launching a probe to, I think, map the stars, like map the universe or something like that.
3D mapping. Yeah, it was really remarkable. And it was delayed. And I'm embarrassed to say I don't recall now if it's actually been launched or not. It was supposed to be, I think, on February 28, and then it got rescheduled. And so we need to check on that. But folks, what we should have said is, if all things go to plan, it'll launch on X date.
Yes, absolutely. So with that being said, that rocket may not have launched, but other than that, all the show notes are accurate. All the links are in there. And ladies and gentlemen, if you want to check out, by the time that you hear this, the show notes will be up. So if you want to follow along, you can see the links, you see the videos. We're going to try to show them up on the screen as best we can. But yeah, the best place if you want more information is always the show notes at computeramerica.com. So with all that being said, Ralph, let's go ahead and just sweep on into story number 1.
You got it. And this first story comes from PC Magazine. This is really interesting. The headline is "No Fiber Needed. New Chip Uses Light to Beam 10 Gig Speeds Through the Air." Tara, that's Tarra, a moonshot project under Google's parent company Alphabet, can now beam internet through the air using a photonic chip about the size of a fingernail. It's a big mouthful there, but this is really very cool stuff.
That's a big claim, and I will say that Google has a very cool culture where, you know, I'm sure over the years it's developed and changed, but they've always said that 20% of the time, or 1 day out of 5 that you work for Google, they want you to devote your time to a project that's like a passion project that kind of does something different that you're not working on, and kind of pushes the boundaries, which is, Ralph, where they kind of roll a lot of their engineers into their R&D part by doing that, essentially saying, hey, in your imagination, what can you come up with? And I think you get projects from Google like this that happen.
Exactly right. It is fascinating to get a larger picture of the Google and Alphabet and the whole constellation of companies and research activities going on within that organization. So getting into the story here, a project from Google's parent company, Alphabet, is debuting a new chip that promises to deliver gigabit internet speeds over the air, no cable needed, as we said in the headline there. The technology comes from Tara, Taara, which has been using light beams to date to deliver high-speed internet without relying on traditional optical fiber. And instead of using a cable, the team at Tara created equipment that can sit on a cell tower and beam light signals through the air, transmitting 20 gigabits per second to another receiver as far away as 20 kilometers, and that's about 12.4 miles. Now, I'll do a little stop here for a second. If you're lucky enough to be looking at our presentation here and seeing the show notes, you'll scroll down and you can see a picture of a fella on a communications tower with this sort of white box about the size of a traffic light. And this is an implementation or an installation that's in the Congo, if I recall correctly, where they're doing this transmission as far as 12.4 miles. Is that part
of the Wired article, or is that part of the PC?
Oh, it would be part of the PC Magazine article, you'll see. And in the show notes, I have the pictures.
Yeah, perfect.
But anyway, so that's what they've had so far. Again, the ability to put these things on a communication tower about the size of a traffic light, transmit 20 gigabits per second to another receiver about 12.4 miles away, just using light beams. So again, in my show notes, I talk about check out the photos in the show notes to learn more. I also have a link in the show notes to give you connection to the Tara project itself, which is very, very interesting. But with that said, so again, what they've had so far, traffic light size on poles, you can see transmitting. Here's the big news, though. The Tara project has since developed a way to condense the equipment, the technology, making it easier to install while also reducing the complexity. And Tara's general manager wrote in a blog post, "We've taken most of the core functionality of the Tara light bridge," that's the name for the thing that's about the size of a traffic light, which is about, well, it says here, the size of a traffic light, and we've shrunken it down to the size of a fingernail. What? And the resulting silicon photonic chip still uses light to beam internet data through the air, but it now uses software to steer, track, and correct the beam of light through hundreds of tiny light emitters embedded on the processor. This is an amazing, amazing chip. In contrast, the original system, which we've been describing, relied on physical hardware such as mirrors and sensors to optimize the beams. Ben, just an amazing achievement if you think about it.
Yeah, and they have little GIFs and whatnot that you can see, and I guess like part of me was like, oh well, where I live there's a lot of trees and there's mountains and hills and stuff like that. Not exactly for me, but like you see some of the places where they're implementing this thing,
right?
And yeah, it makes so much sense when you see how much open land you build these towers, and yeah, you could get miles that you would not have to run cables on. You just have to connect two towers to one another. It makes so much sense when you see where they're implementing it. Like all the drawbacks kind of go away.
Yeah, Ben, and to your point, imagine you see the photo we're showing on the show notes right now, folks, or on our screen, the technician up there with this large object. Now imagine that reduced down to a fingernail-sized chip in a housing. you suddenly have something that's much more portable, if you want to call it that, or manageable. That's the key. And to wrap up this story here, Tara's general manager further noted in the blog post, quote, in tests at the Moonshot Factory Labs, I've got a link in the show notes to that. That's another fascinating story in itself. So in tests at the Moonshot Factory Labs, our team has successfully transmitted data at 10 gigabits per second over distances of 1 kilometer outdoors using 2 Tara chips. We believe this is the first time silicon photonics chips have transmitted such high-capacity data outdoors at this distance. Now, we said before their streetlight-sized device that you show in the pictures could do 12.4 miles, and this is certainly not that. It's like 1/12. But it's early. It's a breakthrough. They'll certainly develop this some more, and you can imagine these being daisy-chained to cover large distances in areas where running cable and so forth might be impractical. So a very interesting communications breakthrough and something to watch.
Yeah, for sure. And this whole, I think you have it in the show notes here for the X stock company, which is not to be confused with X, the social media platform. But no, this is the Moonshot Factory that you were talking about by Google. So
fascinating.
Yeah, they have a ton of different projects. I'm sure that we could do shows just on. Actually, we've talked about some of these. I actually remember the Skip. This was the robot enhanced walking pants.
Right.
Yeah. So very, very cool research being done over at Google. So very cool.
Yep. Salute to those guys.
Yep. So story number 1, story number 2, let's go ahead and scroll on down and let's start talking about asphalt, because if there's one thing anyone who's driven on a city road knows is that potholes, they appear overnight and they get repaired over years. Or maybe never. And yeah, they're a constant problem. And that's just here in America where, we have a pretty good infrastructure and we have pretty good ways of repairing these kinds of things. Not saying that's always the case, but, hey, we repair our roads sometimes. I'm sure all over the world, this is a problem that not only, damages cars, it makes everything look ugly and just prevents the flow of goods and people. So
exactly.
Self-healing asphalt. That sounds amazing. It sounds a lot like our self-healing concrete that we did a little while ago.
Yes. Yeah, you're right on target there. This comes from ZME Science, and the headline here, as Ben was alluding to, is self-healing asphalt could prevent potholes and save costs on vehicle repairs. And this is a story coming out of Great Britain. It's really, it's a mundane topic, but with some fascinating technology to go after the problem. That's the thing I loved about this story. So little setup here for drivers everywhere. Potholes are more than just a nuisance. They're a hazard. They damage cars, cause accidents, disrupt traffic, and cost governments billions in repairs. So great, we all realize that. But what if roads, I love this line from the article, but what if roads could fix themselves? That, you had me. I'm ready. So a team of international researchers from Swansea University, King's College London, and Google Cloud, there's Google again, is turning that idea into reality with a novel self-healing asphalt that could transform the way we build and maintain roads. And Ben, you're going to love this. It's a blend of biology and modern cutting-edge technology. By embedding tiny plant spores filled with recycled oils into asphalt, scientists have created a material that can mend its own cracks. And Ben, that one sentence, tiny plant spores, that sounds cool. Filled with recycled oils, win-win. Here we are talking about recycling things, creating a material that can mend its own cracks. Wow.
It harkens back to the self-healing concrete that we did, which is one of those situations where, it didn't make a lot of sense. And you kind of go into it's like, oh yeah, what if it heals itself? Yeah, that'd be really cool. And then you look into it and it's like a very simple reaction that nature kind of does on its own. You're just, keeping it dormant until it's needed in the concrete itself, or in this case, the asphalt itself. Super low tech, but at the same time, futuristic, to kind of put the two together.
It's incredibly clever. That's one way to look at it. So here's how this works. When the road's surface is compressed by passing traffic, the spores that are embedded into the asphalt release their oil, softening the asphalt or bitumen and allowing it to flow back together. So it's just the pressure of the vehicles going over the surface that trigger this. The spores used in the asphalt are smaller than a strand of hair and are filled with again, recycled oils. It's just such a great concept. In lab tests, this self-healing asphalt repaired microcracks in less than an hour. And I have in the show note, if you want to learn, a little more about bitumen and so forth, the AKA asphalt, we have some additional information. But the researchers working with teams, once again, from Swansea University, King's College London, and Google Cloud, used machine learning to model how organic molecules in asphalt or bitumen behave. And here's some technology for you. The artificial intelligence they used allowed them to simulate the self-healing process and optimize the material's performance. So here you have a mundane thing, potholes. You have this clever idea of plant spores infused with recycled oil, and pressure from cars triggers the result of self-healing. But it was AI that helped them tune the formula to make it just right. And I love that part of it. And to wrap things up here on this one, while the material is still in development, its potential, of course, is enormous. The researchers believe it could be scaled up for use on British roads, and of course elsewhere too, within a few years. If successful, it could not only save millions of British pounds in repair costs, but also make roads more sustainable for generations to come. And Ben, this is a great example of what we do every week. Most of our stories are early research, trends, things to watch develop. And this is a great example. This is still in development, but let's see where this goes. It could save enormous amounts of money and increase road safety.
Yeah, the claim that it can extend the surface lifespan by 30% alone, even if the article goes into the how this needs to go further, but just a 30% extension in less repairs, less damage to cars, everything that you were saying at the beginning, that sounds perfect to me. I don't know what the biggest pothole that you hit was, but I've hit a pothole going on highway speeds, and my teeth cracked. Like the windshield didn't crack, but my teeth cracked. It was really, really bad. So less of that, I'm all for it.
Yeah,
it's really crazy. So really cool stuff. And again, blending, kind of nature with low tech, but at the same time making something futuristic. That is another part of why Ralph isn't just, technology trends correspondent. He's science and tech trends because science is going to lead to advancements. And hey, like you said, AI also helped with that as well. It, made research all that more impactful. Great. So story number 2, story number 3, we're going to go ahead and scroll on down if you're following along. And tardigrades, they're not from Doctor Who, despite what you may think. They're these cool little water bears, I think is the other name for them.
Yes.
They're super cool little creatures. If you haven't heard of them, I'm sure we're going to get a rundown of what they are. But they're really cool, but I never really thought about, kind of using them to, I guess, advance research in cancer research. So let's talk about story number 3.
Yes, this is a good one. This comes from MIT's news website, good old MIT. And what we're doing here, normally, folks, the fourth story, final story that we cover in detail is a medical technology. But this week, there were 2 medical technology related things that I couldn't resist. And this one's a great example. So the headline here from the MIT announcement is, a protein from tiny tardigrades may help cancer patients tolerate radiation therapy. What? How could you possibly resist that headline?
I do appreciate that MIT has a picture of a tardigrade on like a background that you'd see like a superhero, like standing on like a comic book, and it's like the tardigrade, and it's very heroic looking animal. So
absolutely, cool. And freaky weird looking thing, folks. Mm-hmm. If you've not seen an image of a tardigrade, please come out to computeramerica.com, get the show notes, take a look. Your mind will be just blown. But here we go. Let's get into this. The amazing news centers on leveraging something a bizarre creature offers, and I'm talking about tardigrades, also known, as Ben said, water bears. Sometimes they're called moss piglets. They're tiny, water-dwelling microorganisms known for their incredible resilience. These micro animals are typically less than 1 millimeter in length and have a plump, segmented body with 8 legs. These are weird-looking guys.
I relate to them so much. A plump, segmented body. It's like looking in a mirror, folks. It's great.
Amen, brother. I get it. And despite their small size, tardigrades are renowned for their ability to survive extreme conditions that would be lethal to most other organisms. These little guys are amazing. Okay, with that said, let's dive into the article highlights. A little setup here. About 60% of all cancer patients in the United States receive radiation therapy as part of their treatment, of course. Currently, there are very few ways to prevent radiation damage in cancer patients. I think we all are aware of this. Now, there are a handful of drugs that can be given to try to reduce the damage. For example, for prostate cancer patients, a hydrogel can be used to create a physical barrier between the prostate and the rectum during radiation treatment. That's one example, and that's pretty simplistic, right? But drawing inspiration from a tiny organism, again, the tardigrade, that can withstand huge amounts of radiation, researchers at MIT, Brigham and Women's Hospital, and the University of Iowa, so a wonderful team here, have developed a new strategy that may protect patients from this kind of damage. And the key word in that, may. So this is early research, very encouraging, but we are talking about early research. And their approach, Ben, makes use of a protein from tardigrades. This remarkable microorganisms, again, as we've been saying over and over, have incredible resilience. So, folks, in the show notes, you can learn more about tardigrades. I have a whole little section. I dug up information from Copilot AI search and embedded it into the show notes if you want to learn more about these amazing little critters and all these. There's some fascinating facts about them and so on. Check that out if you so desire. But going on here, one key component of a tardigrade's defense system is a unique damage suppressor protein. So a damage suppressor protein, which binds to DNA and helps protect it from radiation-induced damage. So this is the key here, is this damage suppressing protein in these little critters. And this damage suppressing protein plays a major role in the tardigrade's ability to survive radiation doses, get ready for this, Ben, 2,000 to 3,000 times higher than what a human being can tolerate. What? These little guys can handle radiation 2,000 to 3,000 times higher than what a human being can tolerate. No wonder we want to find out how this works and see if it can help people, right?
Yeah, I've heard of them surviving in so many different areas, and I know it's like extreme heat, extreme cold, the vacuum of space, so on and so forth.
Yes.
But I never considered that like a DNA level. It was kind of protecting itself in these ways. Yeah, and a lot of people have said, like, if there's ever a case to be made that there are aliens among us, I've heard it said that tardigrade were like, probably the prime example of an alien. So makes sense now.
They look like some from a science fiction movie, I'll tell you that much. Mm-hmm. So again, in the show notes, folks, you can learn a lot more about the damage suppressing protein and how it works. We've got additional information there for you if you want to geek out and dig deeper. But going on here, it says when the researchers injected messenger RNA, ribonucleic acid, encoding in this protein into mice, they found that it generated enough protein to protect a cell's DNA from radiation-induced damage. Wow. If developed for use in humans, again, this is early research, if developed for use in humans, this approach could benefit many cancer patients. And after showing that these particles could successfully deliver messenger RNA to cells grown in the lab, the researchers tested whether this approach could effectively protect tissue from radiation in a mouse model. Once again, mice and rats, thank you for your sacrifice. And in the show notes, again, I inject additional tutorial information. You can learn about messenger RNA, what this is and what it does and so forth. You can get more there if you wish. And going on, they injected the particles into either the cheek or the rectum of test mice several hours before giving a dose of radiation similar to what a cancer patient would receive in terms of scale, of course. In these mice, the researchers saw a 50% reduction in the amount of double-stranded DNA breaks caused by radiation. So basically a 50% improvement in protecting cells from radiation treatment. So early research, not ready to be deployed to hospitals yet, but very encouraging. And let's see where this goes.
No, the fact that you can reduce the damage that radiation therapy is causing is just amazing. I'm sure most people know at least one person that has gone through that, if not themselves. And, just the toll that it takes on your body, if you can just cut that in half, it's still not nothing, but my God, that would be, really, really, helpful to so many people out there. I'm sure it would just make them
wonderful.
Feel so much
love
better.
It.
So
Love it.
And it's always fun to bring up the tardigrade. It's always such a weird creature, and I'm glad that it's helping us in unknown ways as well, or newly found ways as well. So
yes.
There you go. Story number 3, and like you said, story number 3 was medical news. Story number 4, also medical news, as is usually the case. So let's just go ahead and jump into story number 4.
This is an absolutely wonderful way to end the show on a very uplifting and hopeful note. And that's one of the things Ben and I like to do. We've all had a horrible news week, all kinds of negative stuff. That's not what we're doing. We're going to leave you with this story feeling great. I love this. It comes from Georgia Tech, their press announcement page. Great salute to them, Georgia Tech. Here's the headline. New implant may help patients regenerate their own heart valves. If that doesn't grab you, I give up. Subhead, a 3D printed bioresorbable,
absorbable, but resorbable.
Yeah, it's bio-based and can be reabsorbed. How about that?
Perfect.
So a 3D printed bio-based absorbable heart valve promotes tissue regeneration, potentially eliminating the need for repeated surgeries for adult and pediatric heart patients. Holy smokers, heart valves, that's a whole world in itself in terms of replacement and so on. And so if you're, like Ben said, you probably know somebody in your family or somebody acquaintance that's had to have heart surgery or heart valve replacements and so on. But a little setup here. Every year, more than 5 million people in the United States are diagnosed with heart valve disease, but this condition has no effective long-term treatment. When a person's heart valve is severely damaged by a birth defect, lifestyle, or aging, blood flow is disrupted, of course. If left untreated, there can be fatal complications, needless to say. And a little more setup here. Valve replacement and repair are the only methods of managing severe valvular heart disease, but both often require repeated surgeries that are expensive, disruptive, and possibly even life-threatening, okay? Most replacement valves are made of animal tissue that lasts for 10 to 15 years before they must be replaced. And for pediatric patients, solutions are extremely limited and can require multiple re-interventions. So that's the setup here of what the problem is and to help you really appreciate where we're going to go now with the big news. So now, Georgia Tech researchers have created a 3D printed heart valve made of the bioreabsorbable materials and designed to fit an individual patient's unique anatomy. What? It just doesn't stop in terms of amazement. Mm-hmm. Once implanted, the valves will be absorbed by the body and replaced by new tissue that will perform the function that the device once served. Stop for a second, Ben. What they're talking about is it's something they can put into your heart. It can temporarily replace the valve, but over time, it causes your body to generate its own tissue and eventually replace the artificial valve. There's more coming. You'll understand how this works. But Ben, if this doesn't make you feel better about life and hope, I give up.
No, it's not only providing the scaffold to build the structure around. It's also taking the place of the structure in the meantime, because you can't exactly be like, oh, over 6 months it'll grow and it'll replace the valve over 6. No, you need it now. So this is really incredible that it can do both.
It is. It's just stunning. And going on here says the initial research involved finding the right material and testing different prototypes. Classic science, of course. The team's heart valve is 3D printed using, again, a biocompatible material called, and I'm going to try this, going to have to be slow because this is a mouthful, polyglycerol dodecandioate. I'm guessing that's how you say it. It's a mouthful, but that's the material, this miracle material. And the valve has shape memory. Man, it just doesn't stop. The valve has shape memory, so it can be folded and delivered via a catheter rather than open heart surgery. Wow. And here, this just gets better and better. Once it is implanted and reaches body temperature, the device will refold into its original shape, that is the shape of a valve, that is into the desired shape of a valve, as it just said in the show notes here. And the material will then signal to the body to make its own new tissue to replace the device. What? The original device will absorb completely in a few months. There's so much more going on. This is the good point we need to raise. The show notes, folks, are just highlights, just tempting highlights from the article. If you want to understand more about this profound potential breakthrough, please come to the show notes, get the links, check it out. Salute to Georgia Tech. What a great achievement.
Yeah, to be able to do this, and like I said, pediatrics, the old, the young, the healthy who may be damaged, the constantly sick, like this can affect so many people across the spectrum that it's going to be a literal lifesaver for a lot of people. So it's really amazing, and to see the video, to kind of see the pictures and read the article. Folks, you definitely want to you are going to want to go do that. So with that being said, before my tongue fails, Ralph, those who are following along may notice that, hey, that's not the end of the show notes. Y'all got more to do. Well, that's okay, because Ralph includes stories that he pulls stories that he thinks all of you would find very interesting, very fun. But ladies and gentlemen, it's not like, oh, we can only do 4. There's only 4 good things happening in a week. No, there's a lot more than that. We promise. So we put them in the honorable mentions. These are stories that we just didn't have time for. But if you would like to go to the show notes and find out more information, we're going to give you the headlines, and you can go find out more. And hey, just some fun stuff for you to look at, as well as what's already in the show notes. So, Ralph, let's at least give them the headlines.
You got it. First one here of the 4 honorable mentions. Headline. And by the way, this comes from sciencenews.org. Headline: a private mission to Venus aims to look for signals or signs of life. A probe would bring samples of the planet's atmosphere back to Earth. What? Wow. Check it out. This is really fascinating. Let's go on to the next honorable mention. And that is 11 emerging construction technology trends in 2025. Comes from Construction News and Review, which is a great publication. I'm very familiar with it. For the 10 years I was with Autodesk and in the architecture, engineering, and construction division of their software, I really was familiar with these guys. But this is a fun article. 11 emerging construction technology trends in 2025. My all-time favorite is building information modeling. So go check that article out if you're interested in that. Next one from sciencealert.com. Headline: common mushroom fiber may protect against flu, a study finds. What? Mushrooms, Ben, over the years, you and I have seen story after story after story about the amazing properties and possibilities that can be derived from mushrooms.
The problem
amazing.
The problem with mushrooms is half the population can't stand them. So that's the thing that we have to overcome.
Yeah, well, you don't have to eat these guys. You can make fake leather out of them. You can do all kinds of stuff. And this story has another twist on the good old mushroom. And the last story this week from phys.org, short for physics.org. Physicists achieve fully optical readout of superconducting qubits. Okay, this is super geeky stuff about qubits and quantum computing and all this good stuff, but it's a story from the Institute of Science and Technology in Austria. So check that one out if you're a quantum computing geek and want to dive into this stuff that'll just melt your brain.
Absolutely. Yeah. And we've talked about quantum computers before, so a little bit of background, I'm sure that, is included in there as well. But yeah, there's always a lot of research there as well. So let me just do this real quick. Ladies and gentlemen, like I said, bubblegum today. So let me just pull this up and hit this button right here. There we go. Yeah, we'll use that as outro music. So everyone, I want to thank you so much for tuning into the program. It's been a lot of fun, and actually, let's go ahead and bring Ralph back so you can see when he waves goodbye. We'll go ahead and do that. But everyone, thank you so much for tuning into the program. We hope that you had fun, and we of course enjoyed this. Thank you so much, Ralph, for putting this all together. And ladies and gentlemen, we'll be back every Friday to talk about 4 different stories. You can catch Ralph here. You can catch him over on Dave Graveline with a digital minute, I believe, that you do over there. Yep. And ladies and gentlemen, hey, we'll catch you next time here on Computer America. So have a great weekend. Do something fun. Catch you next time, everyone. Bye-bye.